Ladies and gentlemen, allow me to take you through this another example on Euclidean geometry. Right. What we are doing here, we are not answering any questions, but we are looking at the statement and the diagram. Then we analyze the diagram using the information that is provided in the statement. Right. Let's read the statement and analyze the diagram. Right. In the diagram, ABCD is a cyclic quadrilateral. D is a point on AD such that BG is parallel to CD. It's indicated. EC is a tangent to the circle at C. BD is a chord of the circle. We can see that. Angle GBD is equal to 30 degrees is indicated in the diagram as angle B2. Angle DCE is indicated in the diagram as angle C1. Now let's go. Looking at BG parallel to CD, we can look at two angles there, angle D1 and angle B2, that those angles are alternate angles given that BG is parallel to CD. Right, so meaning that the magnitude of angle D1 is 30 degrees. Right, now considering angle C3, we say angle C3 is equal to angle D1 because we see the tangent which intersects the chord of a triangle. So there is an angle between the tangent and a chord, angle C3. So in that case, we apply the tan chord theorem, which says that the magnitude of angle C3 is 30 degrees. Right. Looking at the angles on a straight line, C1, C2, C3, those are the angles in a straight line, which you know that the angles in a straight line add up to 180 degrees. Then, therefore, it tells us that the magnitude of angle C2 is 90 degrees. Reason angles in a straight line. So in this case now, when looking at the triangle BCD, and now we have angle C2 which is subtended by a chord BD. BD subtends an angle at the circle which is C2. The magnitude of angle C2 is 90 degrees. So if this particular chord subtends an angle of 90 degrees, it means that this chord is a special chord which we call it a diameter. We can say now angle C2 is an angle in the semicircle. So we say DBD is a diameter because BD subtends an angle of 90 degrees at the circle. So now we know that BD is not just a chord but is a diameter. Right. Looking at angle C1 and angle B1, so you can see that, angle C1 is an angle between the tangent and the chord, then therefore, and the chord CD is one side of a triangle. So in that case now we can look at triangle BCD and say we can apply the tan chord theorem by saying angle B1 is equal to angle C1. Applying the tan chord theorem, then therefore the magnitude of angle B1 is 60 degrees. Then therefore we are analyzing this diagram. To analyze the diagram helps us to know that to be able to answer the questions that will follow. So if you don't analyze the diagram, it will make things difficult for you to answer the questions that follow. So in this case now, you can also look at angle A and angle C2. Because you can see ABCD is a cyclic quadrilateral, then therefore the magnitude of angle A is equal to 90 degrees because angle A and angle C2 are the opposite angles of a cyclic quadrilateral. Alright. Alternatively, Since now you already know that BD is a diameter, you can simply say that the magnitude of angle A is equal to 90 degrees because it is the angle in a semicircle. So in that case now you can say then the magnitude of angle A is 90 degrees. The reason angle in a semicircle, or else you will say angle A plus angle C2 are equal to 180 degrees.